WASI PC 2025, that's the second series for NOV, right? For Federal Mathematics or Elective Mathematics, question number 8. The forces F1, which is 6 newtons with a bearing of 030 degrees, F2, which is 8 newtons, the bearing of 075 degrees, and then F3, x newtons with a bearing of theta degrees, keep a body in equilibrium. Find the magnitude and direction of the force F3 correct to the nearest whole number. So we know with equilibrium, for equilibrium, the sum of the forces F1, F2, and then F3 must be equal to 0 to keep the body in equilibrium. All right, so let's see how we're going to add these ones, meaning I have to change these component vectors into column vectors. So my F1 becomes 6 sine 30 and then 6 cos 30. F2 becomes 8 sine 75 and then 8 cos 75 plus F3, which I don't know, so I'll still maintain my F3, all right? And this gives me the vector 0, 0, which is a 0 vector, right? Since we are dealing with vectors. So 6 sine 30 gives us 3, and then 6 cos 30 gives us 3 root 3. Then 8 sine 75 gives me 7.727, and then 2.071. So this plus my third force will be equal to my 0 vector. So moving on and simplifying this, it gives me positive 10.727. Then my y component becomes positive 7.267 plus my third force equals my 0 component vector. So to find my F3, or making F3 the subject, that moves this to the left hand side. I have 10 and then 727 and then 7.267. So simplifying this gives me my third force to be negative 10.727 and then negative 7.267. All right. So they are asking for the magnitude and direction. So magnitude of the third force F3 is now going to be the square root of negative 10.727 all squared, then plus negative 7.267 all squared. There's what I have. So if I find the square root of this, I have 12.957, okay? And now they are asking us to round it to the nearest whole number. And this gives me 13 newtons. So I have 13 newtons as the magnitude. Now for direction, you know, with vectors, we picked our direction from the Cartesian plane. So let's see how to get that. We draw our Cartesian plane. And then since we have a negative component, negative x component, negative y component, we draw our vector for F3 here. This is the vector F3, all right? And then we're going to measure the angle right from the true north till we touch the vector. So that gives us 90 plus 90, so we already have 180 degrees waiting for us. And then we need this small vector, let me name it vector M. We need the vector M, all right? So we join this, and then our x component now becomes positive 10.727, and then our y component becomes 7.267, all right? The ratio to use here is going to be tan, because we form a right angle triangle here. We are dealing with opposite and then adjacent. So tan M will be equal to opposite, which is 10.727, divided by adjacent, which is 7.267, all right? So our M is going to be the tan inverse of 10.727 divided by, we have 7.267, all right? So our M is going to be the tan inverse of 10.727 divided by 7.267, right? So this gives us 55.884. Now our theta is going to be our value for M plus the 180 we already calculated earlier on. So theta becomes 55.884 plus 180 degrees. So in all, our theta becomes 236 to the nearest whole number, 236 degrees. So this is what we have for the force, the magnitude of the force F3, and then the direction of the force F3. Thank you so much for watching. In our next series, we're going to look at the optional part of the WASSCE 2025 PC or second series section B questions. Remember to follow, like, and share for more videos. Thank you.